Maybe we get going. Good morning. Thank you for participating in the session. Extremely excited to share a few things that we are doing in the space of industrial AI. My name is Sudhir Arni. I'm with a company called Sight Machine. We are a Databricks technology partner. I lead ecosystems, partnerships, and a number of business outcomes for the customers that we work with and the partners that we work with. With me here is Bharti Rajan. She is a vice president at Swire Coca-Cola for data and applications. She is one of our key partners with whom we've done a lot of work with Swire Coca-Cola. And I'm going to share things that we've learned and what we are doing, how we are creating impact, how we think about industrial AI. As part of the session, I'm going to talk a bit about what is the inherent challenge with using data from a manufacturing plant to deploy AI, machine learning, or any sort of analysis at scale across manufacturing plants. What we are doing at a very high level with Swire Coca-Cola, along with Databricks, to use this data. And also a bit about Sight Machine, who we are, and what we do. Before we jump in, a quick show of hands. How many of you have tried to use data coming out of a manufacturing shop floor to do analysis? Very cool, okay. How many of you, one more question, have used data from a manufacturing plant, developed some machine learning, and taken the same model, deployed it across 10 plus plants? Okay? That's exactly the challenge what we're going to talk about today. There is a scaling issue with manufacturing data, which hinders manufacturers from using the data at scale to do some really cool analytics. Okay, let's go old school. You look at some interesting trends here. Manufacturing productivity through the 90s, early 2000s, it kept going up. Early 90s, especially in the US and a lot of Western economies, lean as a methodology was adopted from the Japanese manufacturers. There was a lot of process improvements that happened through the 90s. Productivity kept going up. You will start seeing a dip in the productivity somewhere around late 2000s, around 2010. It's either started going down or remained stagnant ever since. On the other side, you will see that investments in being able to use data from manufacturing on the infrastructure, on using the data for analysis, that has kept going up. And this is going to be one of the record years when a lot of money is going to be spent to use that data in manufacturing. And everyone's trying to use that data to solve that question. How do we go to the next phase of productivity improvement? Now that's what begs the question, what is going on? There is a lot of investment. Everyone wants to use the data. There is a lot of willingness to use the data. Then why is it that the productivity has started going down? That's a question that we've been trying to answer. That's a question that we've been trying to work on for more than 10 years now. We started our journey in 2011. We started our journey in Michigan with auto manufacturers. Literally went on the shop floor and started asking auto manufacturers, hey, we can do things with big data. What problems do you have? That's where the company started. That's where the thinking started. And in the last 10 plus years, we've really understood what are the key things that a factory or people on the factory floor are looking for. What are the challenges with the data that exists, which is extremely abundant. Manufacturing produces more data than any other sector. What are the challenges that they're not able to use it? These are the 5 things that we have been able to really drill it down to. It started with hundreds of different hypotheses that we had in mind, but now we've learned enough. We have worked in more than 150 factories across more than 20 countries, across 15 plus verticals in manufacturing. We know what the factories are looking for and what is the challenge. Interesting thing is less than 1% of data, all this data in manufacturing is actually being analyzed right now. The numbers might go from 1 to 5%, but it's actually the number is fairly low. When you go to a factory, People at the shop floor tell you, I want insights in real time. I do not want to know how I solved my problem that happened an hour back or that happened yesterday. And if you go tell the people on the factory shop floor, we will get you there, but these are the challenges with data, they're going to shut down on you. That's not what they want to hear. They say, I want insights in real time. When you try to provide the insights in real time and you start dealing with manufacturing data, the first thing you encounter is the data heterogeneity in manufacturing is extreme. Now that happens because historically manufacturing, all the machine manufacturers, when they were generating the data, top of mind question was not how this data is going to be used for analysis. That's not what people were thinking about, because the software on the shop floor and the machines on the shop floor, machines generating data, that's been happening for 2 decades or more. That was not the first thought about analysis. So the heterogeneity has become extremely high. The asset and process heterogeneity is extremely high as well. We work a lot in the Coca-Cola bottling ecosystem. We work a lot with Swire Coca-Cola. Even within that ecosystem, when all the bottling lines are doing exactly the same thing, it does not mean that the data you're going to find is going to be same. If you have a filling operation on a bottling line, which is provided by a machine manufacturer, a machine that the same manufacturer made in 2020, and you have another line where the same machine manufacturer's filler is running, but the machine was made in 2010, it's going to be extremely different data coming from both of them. That asset and process heterogeneity combined with data heterogeneity makes it an extreme environment. And some of the things that happen with the environment shifting becomes a deep challenge. And another significant challenges is really although there is so much data, no one even knows what the data is. You can go to a number of manufacturing plants, and plants are going to tell you, I have 50 machines that make up my manufacturing process. The number of sensors that I have in these machines, I have had access to that data for the last 10 years. My engineers have had access to technologies such as data historians, which allowed them to create custom tags from the existing sensor values which were there. And today, I have 80,000 tags on my shop floor. I don't even know which machines they belong to. That's the level of challenge that exists. There is another inherent challenge with this data in manufacturing, the way the manufacturing process works. When a product is going through different machines and the PLC information is coming out as sensor value, it comes through programmable logic controllers, PLCs, which are attached on the machines on the line. That data is produced, created at a sub-second level. It's being created all the time. Another thing that you want to do with your products is to start measuring the quality of the product. What you made, is it good enough or not? That information does not come at the same frequency. That information sometimes comes at the end of an 8-hour shift. Sometimes it's even at the end of a day. Sometimes when manufacturers end up recalling their products, the information related to why the product was recalled could be happening 1 year later. But the PLC data is going on coming. And for you to truly holistically understand what's happening in manufacturing operations and analyze, you have to be able to combine all these different data sets, irrespective of the late arriving data, irrespective of data that's coming out of order, irrespective of whether that late arriving data is to the tunes of 1 year late, 1 shift late, a few hours late. Factories want insight in real time. So you got to have a technology that's able to go back in time and restream to the magnitudes of the delays which are occurring with the late arriving data. If you keep all these challenges in mind and suddenly you go to a shop floor and tell them, you know what, you have to solve each one of these problems. Till you do this, you can never analyze your data. They're never going to start. The approach that we have taken, the approach that we are partnering with Databricks on, is what we call a data-first architecture. We've been able to build a stream processing pipeline, a data pipeline, which is fully automating the data engineering process in manufacturing data and providing extremely structured information at the end of the process. So no one has to now deal with all the complexities of the process, the asset heterogeneity, and the data heterogeneity that exists on the shop floor, but you're dealing only with the structured, standardized information that's being spit out of this automated data engineering pipeline with a stream processing infrastructure purpose-built for manufacturing data. That's the data that we make available on Databricks. That's the data that we are making available to Swire Coca-Cola on Databricks so that their data scientists, their data engineers can use this structured manufacturing data set to think about use cases and solving use cases for manufacturing, for supply chain, for customer use cases, or anything. I'm spending a lot of time on the problem because that's exactly what we do with our customers as well. The first step in starting your manufacturing or industrial AI journey is to acknowledge that there is an inherent problem with manufacturing data where existing approaches of trying to do data engineering in a manual way is not scalable. The ROI does not exist. That is why we automated the process. Among all the industrial data sets, as we've been talking about the plant floor data, it is the most complex, but it is the most valuable as well. Everyone has had access, most manufacturers have had access to a lot of supply-related data, to a lot of customer and cell-related data. When you look at a supply chain, you have suppliers giving you materials, you have materials coming in, you go to the manufacturing shop floor. Most of the value-added work for converting those raw materials into the final product that your customers are buying is happening on the shop floor, but that portion, which is the most value-added, no one has any visibility into because of this data challenge. But once you unlock that data, the idea of analytics, the idea of how you create value in a manufacturing organization can be completely rethought. We are doing that with Swire Coca-Cola right now. We are starting a journey where once this data is made available on Databricks, we are beginning to think with them, along with Databricks partners, how can we rethink supply chain analytics? How can we rethink manufacturing analytics? What does that look like? The breakthroughs those are possible are immense. In the make space on the shop floor, you can start thinking about optimizing asset performance. You can start thinking about maximizing yield and improving quality. Reducing energy and resource use, you can really start matching production to demand, not just rely on demand forecasts, but truly make sure that sometimes your production is dictating how much demand your sales force should go and create because the production productivity is increasing way faster than what anyone expected. That's something that we've seen with some of our customers. We've gone and deployed machine learning. We did this in a slightly different setup than the bottling lines. We deployed machine learning applications to start reducing scrap, achieved improvements of 15% reduction in scrap, took the same machine learning, deployed it across 15 other sites. Suddenly, the manufacturer's biggest question was, okay, we can produce more. Our sales teams are now telling us, don't expect us to sell because we never thought you can produce so much more. You start having these strategic questions in the enterprise because now you have access to that make data, which you never had. Typically, what you had was, what is the capacity of my plant? That's it, as a single data set. There's a number of other use cases that can be rethought, but the whole idea at the end of the day, which every manufacturing plant wants, is to empower the front line. The value creation in manufacturing, the Gemba, where everything is happening, is on the shop floor. There are operators who are running the machines. There are operators who know what products are being made. There are line supervisors who are supervising these lines. There are production managers. There are maintenance managers. There's a whole plant management team who's working day in, day out to build these products. All of them want the frontline operators who are running these machines to have the ability and be empowered to make decisions in real time. A lot of times we go to manufacturing plants and we ask operators, do you know if you had a good day? They cannot answer it. They might have some visibility on what the production was, how much their part of the process sort of contributed to the final production, but they cannot tell you if you had a good day because they don't know in real time what are they making, how much are they making as compared to what they were supposed to make. In real time, were they able to make decisions based on the information provided to them that they can say, you know what, my machine was going to go down today, I prevented it. You know what, my machine went down today. Even before I reached out to my maintenance technician, I was able to problem solve myself because I had this data in front of me, and a window on my computer screen told me, do X, Y, Z, the problem will go away. operators are not empowered to that level, although the data exists. If it can be used, all that can be done. We are beginning to now see more and more empowerment of operators happening with the advent of generative AI, which is becoming so big. Once you've structured all the manufacturing data, the information is now available. This information, this structured information, can be fed into LLMs, and you can start querying manufacturing data in natural language, something that cannot be done unless you've structured all this manufacturing data that we've had access to but not usable till now. For the empowerment of operators, a lot of manufacturers are now beginning to tell us, you've got machine data, you've structured it, it's being fed into LLMs, we're getting answers. You know what? We want our standard operating procedures, which have been sitting on binders or PDF files, that to be combined with the manufacturing data in a structured way, feed that into an LLM. We want our operators to start training themselves, reduce the ramp-up time of their training by asking questions of this LLM, give us a query agent, give us a copilot. We want them to be trained much faster than what happened before. It's an extremely significant problem, especially on the manufacturing shop floor in a number of parts of the world where the workforce's manufacturing is aging. There is inherent knowledge with so many people on the shop floor who've been there for 30 years, it's all going to go away. There is young blood coming onto the shop floor. If it's going to take them 20 more years to learn everything that has to be learned, it's not going to work for the manufacturers because everything is all about productivity improvement today. They want people to be faster and faster ramping up. This is where the structured information makes everything possible. Empowerment of the front line can make a lot of the things really, truly possible across the whole supply, make, and sell. And that's, again, something that we are seeing at Swire Coca-Cola. All their focus is on, as our journey starts with them, as they start using the data, it's all about empowerment of the front line. That's what all the leaders of the company are talking about, and we are extremely excited about that. A bit about who we are. I started telling you what we do, where we started. Sight Machine as a company, we started in 2011. We started in Michigan. We've spent all our time in manufacturing shop floor. That's what we do. We are data geeks. We are manufacturing geeks. We are problem-solving geeks. We love being on the shop floor. And we partner deeply with Databricks right now. A lot of our partners, along with Databricks, we work very closely with Microsoft. We work very closely with Siemens, Accenture, Avanade. We work very closely with TeamViewer. Some of the investors that we have are spread across the globe. And the approach we've taken is beginning to show true acceleration in the way manufacturing data can be used. What does a solution look like? Everything that I'm talking about is this solution. The Sight Machine solution is all about structuring data at the core. Everything is about structuring the data. Just like any other industry, just like anywhere else where you want to use data for analysis, you have to do a certain steps. You have to go and connect to data sources, extract that data out. You have to do some data engineering on it to make that data usable. You have to have applications that consume that data, which are then going to be used for visualizing and analyzing. That's exactly what we do, and our platform does all of it. But we don't rely only on what we do. We rely on our whole ecosystem to create value in manufacturing. We have an ability to go and connect to any possible manufacturing data source. It could be transactional systems, IT systems like ERP systems, anything else which has been in place forever. It could be the machines and the PLCs themselves. It could be data historians on the shop floor. It could be MES systems. It could be control systems made by automation providers. We can connect to all of that. But we do partner heavily with a number of other organizations who specialize in connectivity. We do connectivity. We did it 10 years back because it has to be done as a step towards using your data. That's not our core. We do partner heavily with a number of organizations, including Siemens, who helps us do connectivity. And that's what we are doing at Swire Coca-Cola. Siemens helps us with connectivity. They give us the machine data. We grab data from other sources. Then comes our core IP, the structure. I'll talk about what that structure looks like. Sight Machine's core IP is in how do you take data from all these sources, in real time, as I said, stream it, combine it, blend it, transform it, provide context to it, and land it in very manageable set of standardized data schemas. Not 10, 20, 50, 100, but 4 data schemas. I'll talk about what those 4 data schemas are. We use exactly the same 4 data schemas irrespective of which manufacturing vertical we are working with. We use the same data schemas with Swire's bottling plants, with any other Coca-Cola bottling plant. We use the same thing if you're assembling an automobile. We use the same thing if you are making medicines, if you are making chemicals, it doesn't matter. We use the same standardized data schemas backed by that streaming infrastructure and an automated data engineering pipeline. Once the data is structured and standardized and it's being made available in real time, we make that data available on Databricks for data scientists in the organization or anyone else to pick up that data and start building analytics, start solving use cases, either for manufacturing or supply chain or customer problems, anything else, wherever that data is useful, because you have a structured set of information coming to you in real time. We also have our own suite of applications, which typically the shop floor of manufacturing operators, production managers end up using. It's very tailored to their day-to-day requirements of visibility and analysis. Any other applications outside of that, we don't cover the universe of applications, obviously. Our customers, our partners build using whatever technologies they are using. And more, we are seeing our data scientist community is using this data with Databricks to build applications and analytics. We do share that data with anything that our customers have in place, any infrastructure. We make it available so that all sorts of use cases can be solved. I'll talk a little bit about the structuring part and what is it that we are doing with structuring. In manufacturing, you got to be able to explain a certain set of activities. The 2 key activities that you have explained is the work done by your machines when they are running. When they're not running, why are they not running? And then being able to trace the material and product flow through the whole process. If you're able to define that, if you're able to make your data define these 2 set of operations, a lot can be done to analyze manufacturing operations. So when we are taking data from all those sources, and I said we structure and we landed in only 4 data schemas, these are the data schemas we have. The first data schema we have is what we call a cycle schema. Cycles are essentially a data schema which are a discrete event in time in every row of the data table that you see, and each of those discrete event in time is blending data from the machines, from transactional systems, from public information sources for weather information, what is the humidity at the site, what is the temperature at the site. It could be anything. It could be product information, be SKU information. But again, that inherent challenge of late arriving and out-of-order data exists when our pipeline and our streaming infrastructure is blending the data and structuring in those schemas. Our technology is at play, but what we are making available is that single row which keeps being updated every 5 seconds, every 10 seconds, every 3 seconds, whatever the interval the manufacturer wants and whatever works for their process. That's the most foundational data schema, and we define that data schema for every machine on the shop floor. A lot of work was done over the last 10 years where everyone focused on building models of the machines themselves. It did not work. It worked very well, and GE started this when GE Digital was really ramping up. 2011 to 15, GE was an investor in Sight Machine as well at that time. GE built the idea of a digital twin of a jet engine, which was nothing but a machine model of a jet engine. And they were able to scale that from jet engine to jet engine because all the jet engines were made by them, and the idea of digital twins were born. They're still around, and digital twins are still being made and structured and heavily used. But there is a step before building these digital twins that's required, especially when you go to manufacturing, because now you're no longer talking about one jet engine. You're talking about hundreds and thousands of machine manufacturers who've built hundreds and thousands of different kinds of machines. If you start building a model of each of those machines, it's never ending, it's never going to work. The step before that is that structuring, what we do with that cycle data schema, and we are structuring the work done by the machine, which can lead up to building digital twins of any number of machines you can think about. When the machine is down, we do not use the cycle data schema, we use the downtime data schema. It's still working on the timestamps of when the machine went down, when it came back up, as a single row, But it is now looking for downtime reasons, downtime codes, downtime categorization of why the machine went down so that you can analyze and start preventing it and maybe build analytics which give you the ability that the machine does not go down. You catch it before it goes down. Once you define the data schemas for the work done by the machines, you're thinking about digital twins of the machines, of a whole line. The material flow has to be mapped exactly the way the material actually flows through the manufacturing process. There are a certain step of activities, steps that need to be done in the manufacturing process for raw material to be converted into finished goods. And you have to take that into account, how it is passing from one machine to another, what is being done on it, and you have to be able to analyze for a single unit of the product that came out at the end of the line. If I want to figure out correlation between what happened on that product on the last machine compared to what happened as an operation on it on the first machine, you will have to trace the material flow. We do that with the part data schema. Then we have a fourth data schema for defects, where we are tracking quality issues and we are tagging it to the steps in the process where the quality issue either happened or where the quality was measured. Once you've structured these four, you know what's happening in your manufacturing process. You do not now have to go to a PLC to get the machine tag, then go to an ERP system to get the product information, then go to an ERP system for sales order or a production order. You don't have to go to a system which gives you the temperature on the line. All of that is in these four data schemas. You can query it. You can build analytics on top of it. You can iterate your analytics way faster because you can also avoid the drift in the data that happens over a period of time if you've built analytics, because you're building it on top of the structured information. It takes into account things which might be going wrong or changing in the foundational data. If someone changes a historian to another historian, it takes that into account. If someone changes their MES system, it takes that into account. If someone adds a new machine in the process, a new step in the process, it takes that into account. As a data scientist, as a data practitioner, you don't have to worry about the nitty-gritties of what's happening on the shop floor and every time call up the plant to find out why my analytics suddenly stopped working. Instead, you know that from these four data schemas. That's the power of it, and this is what we make available on Databricks. This is what we are doing with Swire right now. We have a fully running production integration with Databricks, where the site machine data platform does what I said it does. It streams, structures, makes the information available onto Databricks. Once it's on Databricks, it's available in the Unity catalog. You can see the schema. You can see what all fields are there in each of the schema. You can define your table structure. You can think about which all fields of these schemas you want to use for the table structure you're thinking about for the problem you're trying to solve. And the problem could be anything. It could be manufacturing problem. It could be supply chain problem. It could be any of those. I'll invite Bharti maybe to just add a few things because it's her team at Swire who's actually doing this work, who's leading the effort. If you want to add something on that, it'd be great. Thank you, Bharti. I'll just leave with some of the use cases that we are beginning to really focus on in the Coca-Cola bottling environment as we work more and more with Swire Coca-Cola. We are thinking heavily about, first of all, what's called a line information system, which makes operators and empowers operators with the ability to reclassify downtime codes. The information is usually not as comprehensive as you would like, which comes from the PLCs. We're helping, excuse me, helping them doing center lining of the process, yield and cost information, make the information available, first of all. We are thinking a lot about raw materials related use cases, focusing a lot on defect-free equipment. These are all the use cases that Swire's manufacturing leadership has helped us with, structure, and think about. Cleaning of equipment is a pretty big deal when you're in a food and beverage sector, chemicals or pharma, extremely big. Setting up the process, qualified staffing. There's a lot of use cases. These are mostly on the shop floor, somewhat cutting across outside the shop floor. But what Bharti's team is now thinking about, along with the data science team, is what are the use cases outside of the shop floor? Some things and some examples that we're exploring are around production scheduling. Scheduling a manufacturing line is typically a fairly arduous job. Schedules are typically developed and provided to the shop floor once a week, once a day. It's very hard to change the schedules to react to any change in demand or any change in supply. We're thinking about how do we take the manufacturing information, blend that with the supply and demand information, and start publishing a schedule which updates every 15 minutes, every 30 minutes, whatever the frequency is. But that's going to be done with structuring and combining all these data sets. And our data science team, along with Swire, is beginning to think about genetic algorithms to be used to come up with that production scheduling. We've tried that in the dairy industry once. We never scaled it. We are hoping to scale that. Some of those use cases also coming to bear now. And that's where the smarts and the brains of all the data scientists comes into play. Once you have this data, lots of possibilities. That's what we do. That's what we focus on. That's why we partner with Databricks, because it's a new data set that we make available to all the users of Databricks and explore possibilities from that. I'm going to pause. I can go deep into any of the other sections. I know we have maybe just 5 minutes left. If there are any questions, happy to take it. Happy to dig into anything else. With Swire Coca-Cola, we're on the journey. Within the Coke ecosystem, we are beginning to see that, where we've had throughput improvement happening, and we are also seeing some very effective use cases of preventing downtimes on equipments. That's in the Coke ecosystem. Outside of the Coke ecosystem, number of them. We've seen scrap reduction that has resulted in immediate bottom line impact. We've seen a lot of work done with predicting quality 3 days from now, which has made sure product information, the product quality is not going to hit your bottom line. We've done a lot of work on improvement of throughput. We've done a lot of work on making your lines just much more flexible with the changeovers, and tremendous amount of work on just thinking about the cost of raw material that you use, cost of energy that you use. In fact, we are launching a solution. It'll be out in the next few weeks with one of our partners in South Korea, where we are bringing to market a power optimization solution where we take power information that will be available for every machine, which is typically not the case in a manufacturing shop floor. So we are partnering with our company, LS Electric in South Korea, where we take the power meters, install it on every machine, combine the power data with manufacturing data, start optimizing power while making sure manufacturing productivity keeps going up. So the blended use cases are also coming into play. But all these examples I'm telling you, very real examples where you've seen actual bottom line impact. We've done some work with AB InBev in the past. I'm happy to go more details into that. Yeah. 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 I can touch on a little bit, yes. We can go much deeper, of course, as any follow-up conversations later. The data pipeline that I'm talking about is a graphical user interface. There is a number of transformations. Those are available as auto transformations in that. Give you some examples of how the data needs to be transformed and then blended. Very simple things typically need to be done. A first step when you're getting all this machine data, you're trying to get this into a wide data set. Take all the machine tags, make a column out of each one of those. Then within all those columns, you're looking for anything that can be used as a key value pair to start connecting the data sets. We use timestamps sometime. We sometimes use material keys or product keys, anything that's available in the data. We're trying to do the transformation and start blending it. Multiple ways to do it, depending on how the process is set up. But the ability to do that easily and iterate with the data pipeline that we've provided data engineers, which is what speeds up the process. Because it's very manufacturing data specific transformations that we've built into the pipeline with our 10 years of experience now. We can, of course, go absolutely much, much deeper into that. Yes. Yeah. So we are doing the structuring within Site Machine and making the data available in Databricks after that. More structuring can be done, but that data set is already structured, and you can use that with other data sets to do future structuring, more structuring on top of that. We do. That is correct. Yes. Yeah. Can be input. It's typically something that we leave to the manufacturing plants. Do they want information and data related to the employees to be part of this or not? Because it can be an identifier of who's working in which shift. Sometimes it makes sense. There is always employee logs available. It could be in Excel. It could be any data source from where we can pick it up fairly easily. In a number of cases, it becomes sensitive because now you can start analyzing in which shift, which operator did the best as compared to others. Most people don't want to do that. But the identifiers are available, and the blending is not hard if the plant is really open about it with the operators and truly trying to upskill them. The possibilities there, capturing the data is no problem. Typically, we've not seen issues with the cost in general. We've been able to do it in a way where the use cases we are solving with that has such high impact that the ROI is significant, because 1% improvement in productivity on the shop floor could be millions of dollars, depending on the scale of the line. It's always really good ROI. That's never been a problem. And our customers usually see that ROI in a matter of 6 to 9 months. Yeah. It's in stream. It's in stream. Yeah. So we have an agent running in Databricks, which is pulling data from our Postgres database and just making it available in the Delta format from there. Yeah, that is correct. It does. We've done some predictive maintenance in a number of industries. One of the examples, we did it in auto quite a bit on welding robots on the assembly line of automobiles. We relied on the torque curves that we were seeing inside the welding robots, not too many vibration sensors. Very effective. Yeah, we were able to provide maintenance crews 5 to 10 minutes notice before a machine would go down. 6 to 9 months. About 8 to 12 weeks, we can configure everything, and the shop floor starts using the platform. It's hybrid. It depends on what cloud or edge strategy companies are thinking about. If there is very heavy hardware within a private network, we can run it on that. But it's usually a hybrid. We can configure it the way the customers want. I think we're on the clock. Thank you so much. Really appreciate you all joining. Thank you.